Hey there, hi there, ho there. Welcome to Unit 2. Just a reminder as we're going through lecture, make sure you're not only listening, but you're also watching, and also keep an ear and an eye open for the super secret code. Let's jump into Unit 2. So last time we left off in Unit 1 talking about the formation of the solar system 4.56 billion years ago, the formation of Earth, differentiation of the different layers of Earth, and the interaction between the layers of the Earth, which leads to plate tectonics. So let's jump into this unit. Now, at some point in the past, the Earth looked like this. We have evidence, we have proof of this. At some point in the past, the Earth looked like this. But it doesn't now. Well, there's only one conclusion. The stuff that the outside of the Earth is made of, the crust, it moves around. Because if it looked like this at one point and it doesn't now, that means these things move. So this is a very famous, what's known as a supercontinent called Pangaea or Pangaea. It might look like a jumbled mess to you, but if I were to imprint the current modern day countries onto that jumbled mess, this is what it would look like. The United States would be butted up right next to Africa. We could walk and drive to Africa, right down to South America. So, a little bit different place. Look, here's Asia, Russia, Mongolia, China, Kazakhstan, etc., etc., etc. But look at where India is. Way down here. So, it's not there now. India now is kind of up in this pocket here. How did it get there? Must have moved. So, where did this notion first start? Where did the development of plate tectonic theory come from? Be careful with that word theory. Highest level of knowing, testable, repeatable, never been proven false, widely accepted. Right? So where did this theory come from? Theory, highest level of knowing? Well, it started with Alfred Wegener. Touched on him very briefly in Unit 1 in Section 2. He was actually a German polar researcher, geophysicist, and meteorologist, a man of many hats. It kind of reminds me of myself. Physicist, geologist, meteorologist. Handsome just like this fellow here. I must be Alfred Wegener. In any case, he's the originator of the concept of continental drift, and he came up with this in 1912. And this concept states that the continents are slowly drifting around the Earth. Continental drift. Continents are drifting. Now, the thing with Alfred Wegener, though, if you remember back to Unit 1, he was kind of just flipping through some maps in a book, looked at the shapes from the continents, looks like they kind of matched up, cut them out, kind of moved them together, and I was like, oh man, these kind of match up. So that was his notion. So this wasn't a theory at this point, this was just his concept. He had no evidence besides the shapes of the continents. So an early proto-Pangaea map, before we knew kind of what Pangaea was, kind of his idea, well, fitting all the continents together like a puzzle, he came up with something like this. So this is the world map of Pangaea or Pangaea, created by Alfred Wegener according to his imagination at the time. And his imagination is actually pretty darn good, because if you look at current, for instance, modern day, this is the continent of Africa and this is the continent of South America. They seem to fit together pretty okay. There's some gaps, but they seem to kind of follow-ish kind of the same pattern. But there's some gaps there. Well, that's going to have to be teased out. But again, on this, just at the surface, it looks very much like these continents fit together. Interesting. So we're going to pause there. We're going to stop there just on this notion of continents drifting around from Alfred Wegener. And when we come back in Section 2, we're going to talk about some of the evidence supporting the plate tectonic model kind of via Pangaea, by looking at this old supercontinent Pangaea. I'll see you back here in just a minute.